Looking at this next set of functions, go ahead, pause the video, take a few minutes, answer 4 through 6 on your own, and then start up the video again to check your work, and I will go over it. So for 4 and 5, we want where it's not differentiable. Okay, that is anywhere you have a sharp turn. So like one straight part of the graph, one straight edge turns into another straight edge. So it's like one line changing directions into another line. So if we look at f of x, it's anywhere you have a corner or a sharp point. So that's at -2, right here at 1, and then at 3. So those are the 3 sharp points in f of x. Okay. Then for g of x, okay, we've got a sharp turn here at -3, at 1, and at 2. So g of x is not differentiable at -3, 1, and 2. Now for number 6, f of 3 and f prime of 3. Remember, when it's just a regular function, when it's just regular function notation, this is the y value of the point. When it's a prime question, you're looking at the slope of the line that point lies on. So for part A, f of 3, okay, I'm looking at this point right here. This is 3, 0. So since it's just a regular f of 3, my answer is the y value, which is 0. For part B, f prime of 4. Okay, so we're looking at 4, we're looking at the slope. So I'm looking at the slope of this line right here. Okay, so I'm just going to count from this point to this point. Remember, to find the slope, you have to have 2 points. You just have to count your rise over run. So this is up 1 over 1. So 1 over 1 is going to make the slope 1. Okay, even if you had picked these 2 points, the 2 ending ones, that would be up 2 over 2. 2 over 2 is still going to give you a slope of 1. So any point that lies on this line is going to have a slope of 1. For part C, g of -2, so this is just regular g of -2, so I'm looking at the y value at this point. The y value here is -1. Then for g prime of 2, I want the slope of the line segment this point is on. So this is a horizontal line. The slope of any horizontal line is going to be 0. If you counted your rise over run, your rise is 0. You didn't go up any over however many over 2 here. 0 over 2 would still be 0. Then for g prime of 4, so this is the slope of this line right here. Okay, so I can't use this point right here to count my slope because the y value falls between -1 and 2. We need it to be at exactly at integers, at whole numbers. Okay, so I'm going to count the slope from here to here because both of these points fall at integer values. That means like no decimals, no fractions. So if I count my slope, that is up 2 over 3. So the slope at 4 is 2/3. So any point on this line right here, excluding these ones with the sharp points, are going to have a slope of 2/3. Then f prime of -1. Again, that's the slope of this line, so I can't use this point, so I'm going to count the 2 endpoints of the line. So that is down 1 over 3, making my slope -1/3. Then for f of 2, okay, I'm just looking at the y value, so the y value there is 2. But for f prime, remember this is at the vertex of a parabola. If you're asked for the slope, which is the prime part, at the vertex of a parabola, that slope is always 0. So we're able to find a slope here because it's a rounded change of direction. So it flattens out for just this 1 second. That's why we say it's 0. At these corners, we can't find a slope because it is a sharp change. Okay, so the vertex of a parabola has a slope of 0. All these other ones with the sharp points, those don't have a slope because they are not differentiable.